After parametric ReLU, we have next ELU, exponential linear unit. So exponential linear unit is very much similar to the leaky ReLU, where in the exponential linear unit, you see that it considers the negative part. Negative part becomes a bit smoother. Okay, so it's mainly focused on considering the negative slope. It modifies the slope parameter of the negative value. So these values. Okay, it induces an alpha multiplier with another equation. So equation is here like this. Okay, so if x is greater than 0, greater than equal to 0 is the same, x remains the value. When it is less than 0, that is where it comes into play, this alpha and one exponential value. Okay, so what are the advantages? So alpha have alpha value is 0.5. Okay, so what are the limitation of ELU? So limitation, as you see, it involves the exponential values multiplied with alpha, so it's going to be time is going to increase. And the next, so there is no learning of alpha and exploiting gradient happens. So this is just the value which you substitute, so it doesn't, we do not learn the value of this alpha. Okay, the next, move to the next. SELU is a variance of ReLU, so it's an upgrade or improvement from ELU, scale exponential linear unit. Okay, it's a variance of ELU. As you see the name, there is a scale, means like it will scale, normalize the value. Okay, so since it involves normalizing the value in the neural network, you may not need batch normalization because it's already been normalized. Okay, this is the advantage of scale exponential linear unit. Okay, so here you say the output is always standardized due to its self normalizing behavior. So the graph is basically like this. There is a slight bend when it reaches the negative value from 0 to 1, 2, 3, slightly bend, and then it's smooth off again. Okay, so the function will be like this. It has a alpha value and it has a lambda value. You see here, this is basically the exponential linear unit. Okay, so this is basically the exponential linear unit. So what is addition here? Addition is the alpha in both the cases. Okay, so what is the value of addition is lambda here, lambda, and the alpha value is nearly equal to 1.6732. And what is the value of lambda? Lambda value is nearly equal to 1.0505. So what are the limitations? The limitations, it is relatively new, so and it's not being performed or it's not being tested properly on many of the CNN and RNN networks. Okay, we need to see how it performs in the CNN and RNN networks. So and it requires this Leach normalization initialization, Leach normal initialization, with initialization. And what is let's go to the next one. Here one, this is a Gaussian error linear unit. Gaussian error linear attempts to combine the features of ReLU regularization techniques like drop out, zone out. Okay, drop out is many of you may be familiar. It will just drop out some of the layers. Zone out is basically it will not drop out, but it will, instead of drop out, it will just take the value of the initial. It will take the initial value. It will not update, but it will just take the initial value. And it has been used in GPU, BERT, and most transformer. Okay, and Gaussian array linear unit is much better than ReLU and exponential linear unit. So this is the graph, and the function is this. The function is denoted by x. Probability of x is less than x, and this is basically nothing but, so this value, so it's what they basically do is they try to represent this value in Gaussian Gauss error function. So Gauss error function is ERF of x, which is again, if you split into, is 2 by pi integration of x missing e to the power t minus d and dt. So when you substitute this here in this of the calculation, you will get these values. Okay, so again, what are the limitations of this? So there's lots of exponential values, 10 8 x of 3. It involves a lot of values, so it is a rather complex and challenging to implement. Okay, then the next, it takes more computational resource and it is less intuitive, means like less understanding. Okay, it's difficult to interpret or difficult to understand. So after Gaussian, then there's another softmax. Softmax is very popular. Okay, in many of the classification we use softmax. It's a combination, you can consider as a combination of many sigmoids. It is mainly used in multi-class, where you have multiple class, like say apple. You have a class like apple. If you want to classify between the fruits, apple, mango, orange, so maybe banana. So such kind of classification we use softmax, when you pass the image, and then the probability of getting apple is how much, probability of mango is how much, probability of orange, probability of banana is how much. So in this, say probability of apple is 0.7, then the remaining will be distributed in the other function 1.5. If it is 1.5, then this probably going to be 0.05. Okay, so it's something kind of this. So if you apply softmax, it is mainly used in multi-class, and then it will give the probability of this. Probability with the highest class is the predicted class. So, and then it is mostly used in the last layer. It's mentioned here, it's mostly used in the last layer. So we cannot draw the graph for this. Okay, so this is a function. This is a function for softmax. Okay, then what are the limitation? Okay, it is very sensitive to outliers and suffer from vanishing gradients. Still suffer from vanishing gradients. Whatever we apply here, all call the activation function. We try to get is being used to implement to improve the vanishing to prevent the vanishing gradient and exploiting gradient issue. So it still suffer from softmax still suffer from vanishing gradient. Then what are the other things? More computational and it assumes that the class are mutually exclusive, which might not be the actual cases. So we see here if Apple is 70%, the remaining 30% is distributed here, but it is not actually the cases. It may not be. Okay. So if there is any unknown object or something like say pineapple is not being trained, but still it will classify pineapple among this, which is uh, which is going to be wrong. So this is what he mean by it's not is we if you consider mutually exclusive, which might not be the actual cases. Or another way, another thing is like if apple is 70%, remaining will be distributed in a 30%. So which may not be the cases. Okay. So the next is switch. Okay, switch is this is proposed by the Google Brain, and it's an as an alternative to ReLU. Okay, it tends to perform better than ReLU in deeper models. Deeper models in the sense that with high layers. Okay, a large number of layers, and it also improves the accuracy of ImageNet by 0.9%, and insertion ResNet version 2 by 0.6%. So, but still, this is simply a variance of sigmoid. So, softmax is a variance of sigmoid. Swiss is also a variance of sigmoid. So, this is a graph. Okay, we slightly bend down and then it will just converge to 0, which if the values are negative. And this is a function. So, you just multiply the sigmoid function with the value x. So it's basically x by 1 plus e to the power minus x. And what are the limitation? It's again it involves exponential values, so it is a little bit expensive and might take a longer time to converse during the training. Non-monotonic, it means that it doesn't either it will not be like increasing or decreasing, something like that. It can go up, it can go down like this. Okay, so that is for the switch. So the next is like when to use what type of activation function. Okay, based on the prediction types based on the prediction types, it can be classified into two: either regression, or in the regression you will have linear activation function. Okay, and other types are the classification. Okay, in the classification you have binary classification, you have multi-class classification, or multi-level classification. So in the binary we normally use sigmoid activation function. So if it is a multi-class, as we mentioned just now, we use softmax, and for the multi-level is a sigmoid. Okay, so there is another type of classification which is based on the layers. So based on the layers, how are they being used? ReLU activation is function is normally used in the hidden layers. For the CNN and for the convolution neural network, we often use ReLU. Okay, then the next, sigmoid activation function. So sigmoid activation function is commonly used in the outer layers of the binary classification. So in the outer layers. Okay, then we have 10H. Where do we use 10A? 10A is frequently used in the hidden layers of mainly RNN classification. And the last but not the least, the switch. Switch, as we mentioned, it is used in deep neural network, deep layers. Okay, so switch is